Hello everyone, how are you doing? Hope you are doing well. Today we are going to talk about the newest feature in EKS world. It's AWS EKS Auto Mode and how it is different from uh, EKS cluster with Karpenter install, which is an open source solution. Earlier this week, AWS announced EKS Auto Mode. As you know, managing Kubernetes clusters can be complex and time consuming. With EKS for Auto Mode, which fully automates the management of our Kubernetes clusters, with a single click, AWS provisions infrastructure, selects optimal compute instances, and dynamically scales resources to meet our application demands. This hands-off approach allows you to focus on building applications without the overhead of cluster management. You don't need to have deep knowledge in EKS. In EKS, Auto Mode, AWS manages core components like compute, auto-scaling, networking, storage. This includes automated upgrades, security patches, ensuring your cluster remains up to date and secure. You can also customize node pools and node classes. I know if you have worked with Karpenter, you know what those resources are. I have some other videos in my channel. You can go and look into that. But those helps to tailor the you know our infrastructure to the workload specific needs. Behind the scenes, EKS Auto Mode uses Karpenter for all its node lifecycle management. So we need to deploy node pools and node classes. Alternatively, having standalone EKS with Karpenter offers a flexible hands-on approach. Karpenter is an open source cluster autoscaler that automatically provisions new nodes in response to the unschedulable pods, optimizing resource utilization and cost. So what we're going to do here is we will try to understand how EKS Auto Mode works. So I will create a cluster with EKS Auto Mode feature, and then I'll create a standalone EKS cluster with Karpenter installed. Then we'll deploy an application. We'll see how Auto Mode scales the nodes and deploys the application, and then with the standalone cluster and Karpenter. One thing we will do is we will also dive into what's installed when a new node is created in EKS mode, compared with standalone EKS cluster. So you will get an idea on what components are installed by default on the nodes and what are not. So these are some of the key features which we need to understand when we are using EKS Auto mode. All right. So let's get started. Let's dive in. We'll explore the key features first, and then we'll go to hands-on session. All right, everyone. So as we discussed about the EKS Auto mode, let's dive into some of the key features what EKS Auto mode offers out of the box. So here is one of my blog. I'll just walk through quickly here, and we'll go through quickly some of the key features. So to start with, as we know, it is very good at streamlining our Kubernetes cluster management, as we know EKS Auto Mode streamlines EKS management by providing production-ready clusters with minimal operational overhead. With Auto Mode, we can run dynamic on-demand workloads confidently without requiring deep knowledge in EKS. So coming to first point, application availability. With Auto Mode, dynamically EKS adds or removes nodes from our cluster based on the demands of our Kubernetes application. This basically minimizes the need for manual capacity planning and ensures the application availability. Next, security. This is the big one. EKS Auto Mode uses AMIs that are treated as immutable for your nodes. These AMIs enforce lockdown software, enable SE-Linux, mandatory access controls, and provide read-only root file system. Additionally, these nodes launched by EKS Auto Mode have a maximum of lifetime 21 days, which you can obviously reduce it, but there is no higher than 21 days. So after which they automatically replace with new nodes. This approach enhances your security posture by regularly cycling your nodes and aligning with best practices already adopted by many of the customers. Next one is efficiency, as EKS Automode is designed to compute cost while adhering to the flexibility defined by node pools and workload requirements. It terminates all the unused instances and consolidates workloads onto other nodes to improve the cost efficiency. So this is purely based on Karpenter principles. Behind the scene, EKS Automode uses Karpenter. So let's talk about automated upgrades. EKS Automode keeps your cluster nodes and related components up to date with the latest patches while respecting PDBs and node pool disruption budgets. Again, up to the 21 days maximum lifetime, intervention might be required if blocking PDBs or other configuration prevent updates. Manage components. EKS Automode includes Kubernetes and AWS cloud features as core components that would otherwise have to be managed as add-ons. This includes built-in support for pod IP address assignments, pod network policies, GPU plugins, etc. And they also provide options for customized node pools and node classes. If your workload requires changes to the storage, compute, networking configuration, you can create custom node pools and node classes using EKS Automode. While default node pools and node classes can't be edited, you can add new custom node pools and node classes alongside with the default configuration. And we will, go through some of these details when we log into the cluster. We will see some of the default node pools and node classes. So as we discussed that there are three component, or mainly from the data plane side, which are managed by EKS Automode now. One is compute, then another one is load balancer, storage, and networking. And you can see here, some of the things what we discussed. It takes care with respect to compute, node management, some of the GPU support options, and auto scaling and the upgrades. With storage, networking, and ELB, you can see it takes care of life cycle of ELB, scaling, scale out, and with respect to ephemeral storage, different volume types, encryption policies, deletion policies. With respect to networking, you get support for IPv6, IPv4, and secondary CRV blocks. All right. So one thing we need to discuss when we talk about core add-ons. If you see, this is one of the presentation screenshot from AWS reInvent where they explain about these core add-ons. Now, core add-ons like core DNS, VPC CNI, EBS CSI driver, they will be deployed as systemd processes. So when you log into your node, you won't be seeing these processes or these pods running as a daemon set. Now they'll be running on the node as a systemd process. So that is a big change. And as a overall, if you see with standalone EKS, the shared responsibility was, you manage the EC2 instance lifecycle, patching, monitoring, everything, and also at the cluster level, compute scaling, storage drivers, load balancing. The same thing with EKS Automode. These are managed by the Automode itself. You don't need to worry about managing your cluster EC2 instance and its lifecycle, and then also cluster capabilities, as it takes care of managing these tools and softwares. So basically, this streamlines your Kubernetes operations, and basically reduces your burden
on the Kubernetes operations. All right. So there are a few things we need to quickly deep dive into. Uh, things like, will I be able to use custom AMI? The answer is no. So you cannot use custom AMI with EKS Auto Mode. You have to rely on the AMIs provided from AWS, and these are by default, these are Bottle Rocket AMIs, which is secure AMIs OS for containers. So the idea is, by putting these restrictions, they want to ensure these automated management processes such as scaling, patching, and updating work seamlessly without user intervention. And also, for that reason, it prevents SSH or SSM access. The next question is, which updates are managed by EKS Auto Mode? As we already saw that, obviously the control plane and then some of the data plane, what we discussed earlier. And suppose, if you want to continue to use your existing Karpenter, and then if you want to make sure which workload gets deployed on EKS Auto Mode nodes, how can you do that? Like, for example, you have a standalone EKS and then Karpenter install. Now you switch the knob on the EKS where you convert to EKS Auto Mode. So you want to use the benefits of Auto Mode, but also you have a custom AMI requirement, for example. So how do you make sure that the pods which you are deploying are not going to get scheduled on the EKS Auto Mode managed nodes? So you need to make sure, as usual, you need to follow the Kubernetes constraints node selector, and this is the label you should use, eks.aws.com/automode true. Now you need to make sure that the workload which needs to be deployed on nodes created by EKS Auto Mode should have this node selector. Then you can make sure add this combination of node affinity and tail centralization to make sure no other pod gets scheduled on those nodes. All right, so I will share these blog details in the description. So let me know if you have any questions. Okay, so before we get into next section, I want to discuss, the difference between AWS EKS Auto Mode and then EKS with Karpenter. These two powerful options are really great at managing Kubernetes clusters on AWS. Both approaches, offer unique benefits and cater to different use cases depending on the level of control and flexibility you need. So let's start with first, obviously, the control plane management fully managed by AWS in both the cases, but in Auto Mode, there are a few more abstractions done from the users. Compute scaling, automated scaling managed by AWS, but behind the scene, Karpenter is doing all the magic. And EKS with Karpenter dynamically scales nodes based on the workload needs. Node management, automatic node provisioning, and rotation by AWS. Here, user-defined node configuration with flexible provisioning. You need to define all the configuration through node pools, and then the EC2 node class. Custom AMI support. It's not supported with the Auto Mode. You cannot use any custom AMIs. Everything is managed by AWS. Here, custom AMIs are supported, and you don't have any restrictions there. Next, on the networking, AWS manages VPC, CNI, and other core add-ons and components. Here, users need to manage these components. All the built-in add-ons, what we discussed, are managed by AWS. User needs to install and manage these add-ons, as we will see in our hands-on demo, where we go through the AWS console and see the add-on sections on the EKS console. Resource optimization, AWS dynamically adjusts node configurations. Here, Karpenter does that, but you need to create the required configurations. That is node pools. User control, it's minimal. AWS handles most of the tasks. It's high compared to Auto Mode. Users need to set the scaling and provisioning policies. The last one, coming to ideal use case, best for users who want the zero infrastructure management. And here it's very ideal for users needing high flexibility and custom node configurations. Okay, so these are the very high level comparisons. Let's go into cluster and dive into some more details with respect to what's installed and what's not installed with respect to auto mode and EKS with Karpenter. All right, so if you see here, I have two clusters. One is with auto mode and one with EKS plus Karpenter installed. So when you log in to a cluster with EKS auto mode enabled, you don't see any pods. There is no Karpenter installed here. You don't see any Karpenter pod or anything like that. It is managed behind the scenes. And so that's the reason you're not seeing any node here. But the same thing if you go to the EKS plus Karpenter configuration, you will see one node because you need a managed node group or a Fargate instance to deploy the Karpenter. And then with Karpenter on that node, you will see Core DNS, AWS, VPC CNI, and kubeproxy. Okay, and let's check what node pools and node classes by default is deployed on the cluster. Now, according to AWS, with EKS Auto mode, they deploy two node pools. One is general purpose for your standard web app and APIs, and then the system one is for critical add-ons. If you describe the, let's edit it so that you can see the configurations of node pool. So you can see they have set the budget of 10% and consolidate after 30 seconds. So if the node is empty or underutilized within 30 seconds, after 30 seconds, it's considered for deletion. And now expire after this 336 hours. I think it's 14 days, and you can extend till 21 days. If you see the requirements, the instance category, they have just set to CMR category. They're not setting any custom instance type because they want this to be very generic for all the workloads. Okay, all right. Now let's go and check for node class. So this is the default node class which gets installed when the cluster is created. And let's edit this. Okay, you can see here the API version is different and the kind is node class. If you see the with Karpenter, the kind is EC2 node class, and the API version is also different there. Okay, so here, as usual with the EC2, with the node class, you provide the role, security group selector, subnet selector. This is all identified by the Automate itself, and it has created this configuration. Okay, and as here you don't see any AMIs because AWS manages the AMIs. So that's the reason you don't see any AMI details here. They don't allow you to select AMIs as we discussed earlier. Okay, now let's go ahead and deploy a simple app and see the EKS Auto mode in action. Go here. Right. Okay, so you can see here the app is deployed on the cluster now, and let's wait for the node's creation. In the meantime, we can see if the node claim is created. Yeah, you can see the node claim is created. Let's see, it's 23 seconds, and it has selected C6A large node. There you go here, node is also created and it's ready. The pods are getting scheduled. Now, if you describe on the node, let's describe on the node. Pods are ready now. You'll see there are custom labels applied by the EKS auto mode configurations, and then go down here. You will see what AMI is selected, all those details. Let's go down here. You can see here OS is Bottle Rocket. This is the default AMI AWS uses for all the nodes created by auto mode. And let's go and see the events for the node. And you can see here there is a new component called Cloud Node Controller, which registers the node with control plane. Okay, now as we were discussing that all the core add-ons gets deployed as the systemd processes, so you shouldn't see any of these pods in the node. So if I hit enter here, if you see only these 3 pods are scheduled on the node, and there are no kubeproxy or VPC CNI, or core DNS. You don't see any of those pods. So that is one major change or update with EKS auto mode. Okay, so now let's go, to the EKS plus Karpenter configuration. See here, let's deploy. Before we get into the deployment now, as I was telling you, on the node, you'll see all these core DNS, kubeproxy, AWS node. This is how it is with the EKS plus Karpenter setup. Okay. Go ahead and deploy the application. Let me make sure. Okay, so before I deploy the app, let's make sure we have the node pools. Okay, so I already applied the custom node pool, and then let's make sure we have EC2 node classes. Yeah, so both are present. I'm just gonna go ahead and apply the app here. Okay, so deployed node claim. Okay, so already Karpenter has decided that it is going to launch T3 medium and its spot capacity. By the way, in case of EKS auto mode, by default, they have on-demand node with the node pool configuration, what they have provided. Obviously, you can deploy a separate node pool with the spot configuration. That's totally based on your requirement. Okay, the new node is created here. It's coming up. So as a new node comes in, with that, you will have this kubeproxy AWS node pods too. Okay, all right. Let's log into EC2 console and let's check what differences you see on the EKS console. Yeah. Okay, so if you see here, I have 2 clusters created. The first one is EKS auto mode, and now if you see in the, let's see, overview, EKS auto mode, it shows enabled. And then if you go to compute, you can see built-in node pools. You have general purpose system node pools, that we discussed about that. And then let's go to the add-ons view. you can see here, you don't see any add-ons here because that is all managed by Automode. You don't see anything here. All right, so let's go to the standard EKS cluster where Automode is disabled. And if you go to compute, you should see one node which is created here. Yeah, the node groups, which is a managed node groups for Karpenter. And then add-ons, so as you see, kproxy, CNI coordinates, these are all managed by us. So these are not managed by AWS team. So you need to make sure you update these versions whenever you update your cluster. And basically needs to be managed by the user. Okay. Yeah, I think that's all I wanted to go through today. Let me know if you have any questions. Drop me a message in the comments. And as we continue our series with Karpenter and then the EKS Automode, I'll try to add more videos. And probably next series will be, how do you migrate from your existing EKS plus Karpenter setup to EKS Automode? What are the steps you need to take care, and also from manage node groups to EKS Automode. All right, so until then, keep learning, guys. Talk to you soon. Bye-bye.